In this video, we're going to look at the third type of projectiles. So let's take an example. A particle is projected from a point O with a speed 35 meters per second at an angle of elevation of 30 degrees. The particle moves freely under gravity. Find the length of time for which the particle is 15 meters or more above O. So, as what we always do in mechanics is we draw a diagram. So let's draw the point where it's projected from. Here's the speed. Particle moves, is being projected like this. We've got our speed as the velocity. Like so. And don't forget, speed is the magnitude of velocity. So that's 30 degrees here. This is 35 meters per second. And let's draw in our components of the velocity. So going horizontally, we have 35 cos 30. And the vertical component of the velocity is going to be 35 sine 30. So I'll just write that here. 35 sine 30. And you're going to see why in a moment. So what the question stating is that what happens is there's a point, say at 15 meters, if we were to draw that here, where the particle at some point is 15 meters above the plane. So if I was to draw a dotted line here, like so, we're interested at this point. But if we notice that the particle reaches 15 meters at two particular points, right? So it reaches it first at 15 meters at this point. It keeps moving along, and then as it comes back down again, it also reaches the same displacement above the ground, 15 meters, at a second time point. So I'm going to call that time point time 1 or T1, and I'm going to call that time point T2. So we have two different time points when the particle reaches 15 meters above the horizontal ground. So let's do a SUVAT and take it upwards as positive. So taking upwards as positive, we're going to do a SUVAT here. So A is minus G. U is going to be the vertical component of the velocity, so 35 sine 30. So let's write that in. But we're interested when it's 15 meters or more above the ground. So I'm going to say S is 15, and we need to know the time. So the SUVAT equation we're going to use is S equals UT plus a half AT squared. So we can say 15 is equal to, well, half of 35 is 17.5 because sine 30 is a half. So we get 17.5. If you want to, you could write 35 sine 30. I think it might improve the clarity if I write 17.5 here. Now we can say that 17.5 S is 15 first. So 15 is 17.5 T minus, or half of G is 4.9, so it's 4.9 T squared. So we could rearrange that for this quadratic. So 4.9 T squared minus 17.5 T plus 15 equals to 0. Now, we can use our calculator to solve that, as we've shown in previous videos. So if it's alpha and minus, polynomial, it's a quadratic. Let's type in our coefficients, 4.9 minus 17.5 and 15. And the calculator will give us 2 time points. So we get 10 over 7 and 15 over 7. So I'm going to say T1 is the smaller time point, which is 10 over 7. T2 is 15 over 7. As you can see, we've got those results from our calculator. 15 over 7 and 10 over 7. So, but what the question states is find the length of time for which the particle is 15 meters or more above O. So it reaches 15 meters at both of these time points, the particle. So if we subtract them, we get the length of time that it's 15 meters or more above O. So we require 15 over 7 minus 10 over 7 is 5 over 7 seconds. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. A projectile is fired with velocity 40 meters per second at an angle of elevation of 30 degrees from a point A on horizontal ground. The projectile moves freely under gravity until it reaches the ground at the point B. Find the distance AB and find the speed of the projectile at the first instant when it is 15 meters above the ground. So, as always in mechanics, we draw a diagram. So let's start off by drawing a diagram of our projectile. So it's projected with a speed of 40 meters per second. So, or velocity, we're going to take its components in a moment. The speed is the magnitude of velocity, don't forget. At an angle of 30 degrees from a point A on horizontal ground. So this is A. Here's our projectile motion. So let's draw the horizontal ground. And this is the point B. So they tell us that the angle involved, that's going to be 30 degrees. Let's resolve this into components. We'll take components of our velocity. So we have 40 cos 30. Sine 30. And then like we had similarly, we need to find the speed of the particle when it is 15 meters above the ground, as in the previous example. 15 meters, like so. So that's interested in 15 meters. So what is that speed? That's what we're interested in. So first of all, let's find the horizontal displacement. So first of all, we need to work out the time of flight. So I'm going to do what we've always done in previous videos. So I'm going to work out the horizontal displacement first. So it starts from 0 in terms of displacement and ends up at 0. So that's why I've drawn a little 0 there, just to remind you that's 0. So S is going to be 0. U is going to be, in the vertical sense, 40 sine 30. Well, 40 sine 30 is simply 20. So you can say that's equal to 20. And A is minus G. And we're trying to find out the time of flight. So to see that equation we need is S equals ut plus a half at squared. So S is going to be, well, S is 0 in our case. So 0, so it's 20t minus 4.9t squared. 4-bit clear. So 4.9t squared minus 20t equals 0. You can factorize that to be 4.9t minus 20. So our 2 time points we want are as follows: t equals 0, or 4.9t minus 20 equals 0. T equals 0, or t equals 20 over 4.9. So because we want the horizontal displacement, I'm going to leave it as 20 over 4.9. So what does this mean? It means that the particle is at the origin at time t equals 0, or at displacement of 0 at time equals 0, and it comes back to 0 at time 20 over 4.9. So we need the horizontal displacement, so taking the horizontal or taking the horizontal sense, like so, S equals ut. Now in our case it's going to be it's going to be 40 cos 30 times 20 over 4.9. So S, we can do that on our calculator. So it's going to be 40 cos 30 times 20 over 4.9. And that's going to give me 141.391. And so on. I'm just going to round that to 3SF. So 141 meters to 3 significant figures for part A there. Now notice for part B, it says to find the speed of the projectile at the first instant when it is 15 meters above the ground. So again, we're going to do another CVAT here. So let's do that here. So we're going to do a CVAT. Taking upwards as positive. A is minus G. Displacement's 15. We said U was 20. And we need to find the speed of that. So let's do that. So we can find the velocity. Before you can find speed, you need to find the velocity going horizontally, the velocity going vertically. So we find the velocity going vertically. Now, when it goes vertically, I'm going to call that Vy. And when it goes horizontally, I'm going to call that component of velocity Vx. So what we're working at essentially is Vy. So we can use the CVAT equation, V squared equals U squared plus 2AS, like so. So V is going to be 20 squared minus 2G times 15. Don't forget G is 9.8. So we can do that straight away. So we can say 20 squared minus 2 times 9.8 times 15, which gives me the square root of 106. So don't forget, I'm going to call this Vy. Well, what's Vx? So all of this is referring to Vy, the velocity in the vertical sense. What's the velocity in the horizontal sense? Well, if we go back to our diagram, we know what that is. That's 40 cos 30. So I'm going to write Vx as 40 cos 30. Now, as I've always alluded to in this video and previous videos, is that speed is the magnitude of velocity. So we're going to have to use Pythagoras. So it's going to be the square root of Vx all squared, as in the horizontal component of velocity squared, plus the vertical component of the velocity squared. So in our case, we are doing this calculation, 40 cos 30 squared plus root 106 squared. So if we do that on our calculator, so we're going to round this to 3SF, so the speed required is going to be 40 cos 30 plus 106, and that's going to give me 36.1 meters per second. So I'm going to say 36.138 and so on. Therefore, the speed required to 3SF is 36.1 meters per second. And that's been rounded to 3 significant figures.